Okay guys, so just going back through and decrease the number of points used and filtered, just to get something a bit more what I'm after for this tutorial. So what we're going to do now is we could essentially, we could put a break in our workflow, right? And we're going to be, just represent that with the data now, because that's what it is. But now we've got what is essentially a flattened list of a whole bunch of curves. Well, they're technically lines, which is good. And you see I've got a whole bunch of weird geometry floating around. I'm going to show you how we can start to make sense of an unordered list of geometry. And we're going to do that with a component called RNet. Rebuild network. That's it. Rebuild network is under the networks tab of one of my favorite plugins called Heteroptera. Put a link to that in the video down there for you guys. What it essentially does is recreates line from topology or convert different type. Okay, that description's a bit weird, but anyway, what it does is it's going to help us bring a logic to this curve network. And once we've got a logic to this curve network, we're going to work out what curves are in the network and what aren't, i.e. these little get rid of these buggers. So what we're going to do is plug our lines into here, curves optionals list. And what this is going to do is it's going to give us all the connection nodes as points. So they're essentially all the points on these lines. It's going to give us all these lines back out. Great. And it's going to give us something called a point topology as a tree, and a connection topology as a tree as well. So let's have a look at that. So what this is, it says, okay, what do we have? We got 247 branches there. And we also have, is it 247? Yeah, but it's 248 branches, sorry. And we have 248 points. So for every one of these points, let me just simplify that list. Point 0 is connected to point 1, 3, 85, sorry, 1, 3, 83, and 102. Let's prove that now. I'm just going to do this really quickly. 1, 3, 83, 102. Not that cool. Multi-line data, bang, bang, bang. So that's those ones. And let's have a look at actually point 0 now, this one. So technically, if I draw a line between here and here, I am recreating this connection. So technically this should exist, and what if I bake it, group it like so, and I'm just going to go. So I worked out if I press F10, it stops recording my computer, so I have to go points on. Right, so then when I click back on here, we can, how do I prove it? How do I prove it? I'm not going to prove it. But anyway, this is how the whole thing works. So that's point 0. And what we have here is let's have a look at our connection. What do we have? Here we go. This is how I'm going to prove it, actually. Our connection topology. So this is the topology of connections related to nodes. So it's a pair of points, right? So I'm going to simplify that one as well. Cool. So here I've proved it. Point 0 here, point 0, our first connection is point 0 is connected to point 1. And yep. Point 0 is also connected to point 3. Point 0 is also connected to 83. And it's also, it's connected to 102, but that's not here. Maybe that's further down the list. Let's have a look, see if we can find it. (102) is connected to 0, so it's the other way. So there we go. Great. So we can get rid of that. And we can get rid of that. So let's get back onto the task at hand. So the first thing we want to do is, now we've turned this raggedy network of lines into an order. Now we know a bit of data about it. So what we're going to do is get rid of all these. So what we want to do is if only one point, if one of these points only is only connected to another point, it's essentially going to be a floating line. So we're going to, if that's the case, we're going to delete that line. That's what we want to do. So we're going to use this information to help us do that. So I'm going to use tree statistics and list length. Cool. So we're going to call, like, if we have one of these lists with only 2 in it. Oh, is it 1 in it? Sorry, 1 in it. We're going to get rid of it. Let's just do that now. Set that up. So the list length equals 1. It'll start to make sense the more we build it. Carl pattern. This one, and I'm pretty sure I want not equal. Oh, better plug that in. Like so. Let's just sort of get this aligned a bit more. Beautiful. And then we're going to just list those branches that haven't been culled. So we're going to do that. And then list item going to be used to list all these points. And then we also need to, let's need to have a look at some things first. Yep, need to flatten that to match those up. And no, I don't need to, but just in case, simplify that. We need to cull these points also. So that should cull all the unneeded points now. Yes. We'll see how we go. And then now we need to redraw some lines between the ones we've culled. Between the ones we haven't culled and then typology. The other topography. Sorry. And the other topology. So to align between every one of these. And these should all 160. I don't know, do we want 160? What do we got? Let's have a look. 4. Oh, okay, we haven't cleaned that up yet. It should work. Oh, it looks like it's worked. Yep. Yep, there we go. They're all disappeared now. Wonderful. And because it's a little bit weird the way we've done it, but it means we've kept these other lines as well, which is good. Cool. So what we're going to do now is we have some structured data, but we don't really need it that structured anymore. But we're going to remove duplicate lines. That's a kangaroo one again. 412, 415. So there's a couple of back and forths in there, but that's all right. We've taken care of that. And there's always, I think, the thing about this workflow is it may create lines of 0 length. I can't see any, but let's just do it. It's a good little catch function. We're doing larger than 0. Color pattern. Cool. So we'll get rid of any line that's either. Oh, that's right. That is less than 0 or 0 or less. 402, 409. So there's a few in there. And you know what? We kind of don't need this structure anymore, so we're going to flatten them, which is great. And again, this workflow, like, it's pretty lean, so I could come back and, you know, change this to, oh yeah, let's just do it. Plug that in. What if we went, this takes a while, but, you know, there we go. Added a bit more density to it. Yeah, we'll do that for now. It looks kind of cool. Awesome. So, that's it for this video. In the next video, we'll take it into Karumba, I think. So Karumba is a finite element analysis software plugin for Grasshopper. It's a paid plugin, so we're going to use the university computers, virtual computers, to do it. So I'll see you virtually then.